About 300 people across the world have been frozen and cryopreserved in the hope that in the future they can be woken up to a better life. But what are the long-term implications of cryopreservation? In particular, what are the effects on the brain? Will their personality be the same when they wake up? Will they remember their previous lives? So do memories survive cryopreservation? Well, according to the Daily Mail a couple of weeks ago, they do, at least in worms. Worms are the only organism which we can cryopreserve, in that we can freeze them, thaw them, and then they'll carry on to live their normal life. So how do you test for memory in worms? Well, to do this, the researchers had to imprint them, and they did this in a similar way to how Pavlov conditioned his dogs. When the worms were very young, whenever they fed them, they exposed them to a certain smell. So the worms learned to associate this smell with getting food. They then froze the worms, woke them up, and tested, can they still remember this smell? To do this, they put them in the middle of a dish, put the food smell at one end and put a different smell at the other, and counted how many worms swam towards the food smell. And they found that twice as many worms who'd been imprinted swam towards the food smell as worms who haven't. So it looks like, yes, this particular memory can survive cryopreservation. And you can see why this kind of memory would be important to preserve. Worms who can associate a certain smell with food are more likely to find food, and so are more likely to grow bigger and reproduce more. And similarly, evolutionarily important memories have been shown to be preserved in mice. So mice who are taught to fear a particular smell, the offspring of these mice fear the same smell despite never having smelt it in their lives. And in fact, if the offspring mice are produced by IVF and raised by a different mother who's never smelt the smell, they still learn to fear the particular smell that their parents were conditioned against. So this shows that the memory was inherited, it wasn't taught to the parents by the offspring. When this was examined further, they found that when the adult mice were taught to fear a certain smell, it caused modifications in their DNA, which altered expression of some of the genes. When they examined the DNA of the offspring of these mice, they found the same modifications. And so that explains how the fear memory had been passed from the adult mouse to the child mouse. The important question is, are your memories stored in a similar way? And the simple answer is probably not. Your memory of a walk in a park, for example, is a lot more complicated, and we don't really understand how these memories are stored, but the best guess is neural networks. So if you imagine that each of these black dots is a cell in your brain, every time you experience something new connections are formed between these brain cells, and these form a network, and it's this network of cells which stores the memory. If you break the network, you lose the memory. So, do these neural networks survive cryopreservation? Well, at the moment we simply don't know. We haven't tested how the worm's memory was stored, and we don't know whether the worm's neural connections survive cryopreservation. So, to go back to the original question, when these cryopreserved people wake up, will they still remember their memories? We simply don't know.